Okay, we're going to move on with the rest of the presentations. We have a couple of more presentations before we wrap up this edition of Google I/O Extended Sri Lanka 2018. A small man with big dreams, passionate technologist, developer, entrepreneur, and a visionary. He has nearly 5 years of experience working with Google Developer Group in Sri Lanka, and as the founder, then joined Google in early 2014, leaving GDG. Before joining Google, he worked as a freelance software developer, project manager for nearly 6 years, and worked at IFS as a software engineer for 2 years. He co-founded Siomec in 2013, which targets IT solutions mainly in agriculture. Ladies and gentlemen, we are ready to talk to you on Can AI be the next Mozart?
Next, please welcome Keshan Sodimana, Google Engineering Consultant.
Good morning. Hello. Good morning. Katira Mahasi the Natala. Okay. I'm excited to be here today in front of 3,500 people. I'm a bit nervous too because I haven't talked to an audience of 3,500 people before. And also talking during this kind of Yakku Gasanagina time, I feel a bit nervous. So first of all, I would like to thank the organizers, GDG Sri Lanka, and the Ideamart team, and also the sponsors, Dialog, Asiata. Can you give a round of applause for the organizers and the sponsors? Thank you. So, the question for me, can AI be the next Mozart? Do you think so? We had a wonderful session just now by Sanuka. He actually changed our we were like sleepy, like I knew some of guys were sleeping back then. But now I see like most of you guys are awake and you are like really energetic. So music is something that AI probably can't emulate, right? That's what you think. And if you just think about music and art, it has some patterns. So what we are doing with machine learning usually is understanding the underlying patterns of those data. So can AI be the next Mozart or Picasso? So when you think about artificial intelligence, usually music and art doesn't come to your mind. Am I correct? You think of robotics, maybe some self-driving cars, or maybe something different like sci-fi, like science fiction stuff. But have you ever thought about music and art, which can be done with machine learning? So, especially not just music and art, if you think about texts like jokes, how do you create jokes? I mean, how an artificial intelligence system can create jokes? How do you define a joke? Why jokes are jokes? For us, we take it as granted because for us we don't understand. We just simply laugh at something some people say, but it might not be a joke or something laughable to somebody else. So how do we define jokes? So those are big questions. Still, most of the research teams across the world are researching on. So how can machine learning compete or come up with answers for these things? I think the answer lies in the time. So with the time, I think most of these questions will be answered. So until then, I will just look at what we have today. So if you think about the electric guitar, do you know what is the initial purpose of an electric guitar? So electric guitar was initially created to make a louder acoustic guitar. And the distortion was a failure, actually, at the time, when they created this electric guitar. Do you know that? I think some of the music people who might know this story. And this distortion, lately, after it was created, some creative people came up with and used this distortion and created some amazing music. So in the recent past, we had seen some amazing masterpieces using this electric guitar. So did that affect the classical or the acoustic guitar? No, it just give another dimension to the music or the new dimension to this guitar industry. Same goes for the video camera. So at that time when they created the video camera, it was just a gadget which could just record the reality. And the high exposure was a failure, as similar for the electric guitar. And at that time, people were just thinking about paintings. The artistic things were just paintings. They didn't think that people could use this for creative effect and create a multi-billion industry like movies industry. So what I think, this is my personal opinion, the music which we generate, not just music or the art that we generate with machine learning is not a replacement for the current music industry or the art industry. It is just they can complement each other. And it could be maybe another genre or maybe something totally different industry. We have to wait and see what will happen. With that, okay, so I will play something for you. Just listen to this. Okay, do you see a difference? Do you know who was the composer of this sound clip? Are there any answers? Who was the composer of that track? Well, it was composed by a neural network. Do you believe? And the project behind that, the piece of track was TensorFlow Magenta, which is an open source project, open source by Google, and it's available for everybody. All the source code and the data are in TensorFlow GitHub repository, so you can find out all the information about it. And it is not just for the developers. So there could be some people here who are not developers, but who are really music enthusiast people who have good knowledge in music. So these are the communities, or these are the people that these kind of projects needs, not just the developers, because not all the developers are really creative in the sense of art and music. So it is the ecosystem that this project Magenta is trying to. Okay. It's nice because, oops, okay. Right, so this is the Magenta project. You have artists and musicians. So let's say if you train a neural network with, let's say, Beatles music from Beatles, and if the neural network can come up with hundreds of thousands of Beatles music, which are similar to Beatles, but not Beatles. Is it really worth? I mean, if we just generate music at will, would that really good? We don't need that. It will simply destroy whatever the good things that it had. So what here we do, it does is, it goes through the developers and then go to the artists and musicians, and then they can give the feedback or change some of these things and listen to them, change something else, some things in that music piece, and then they can use the creative tools which were developed by the developers or the programmers, and then all these things will be open source. So the open source community is not just developers. Again, I'm saying that it's not just developers. Open source means not only for developers, it can be musicians, it can be somebody else who love to listen to music. And then they will go through some of the researchers. So the people who are doing research can see all this stuff and then come up with new models, which can then be reviewed by the musicians and artists. So the cycle will goes on, which means you will get better models, better music, better arts using these kind of machine learning platforms. Right. Some of you might know this. So autoencoder is a type of machine learning neural network architecture, you could call it. So don't think about it that much. Just think it as so here we have the input, and there's something called encoder, which in technical terms is here it's a LSTM, a neural network, but just think it as it is something that from the input you learn the basic features, and you come up with something called Z or Z, whatever you're comfortable with, and this Z is a basic representation, a minimum representation of the input. So in technical terms, it's a vector or could be a matrix. So that vector is a low-level representation of this input. It could be an image, it could be a wave file, it could be anything. So here we will talk about the audio and the image files, and this representation, since you're making you simply reduce the dimensionality, you will just forget about some of the anomalies or maybe some of the unimportant features of that particular sound or the image. Right? You get it? Then what we do is get that basic representation and then use something called decoder, which is also similar to the encoder. It's again a neural network architecture, and then it will recreate. It will try to reconstruct that representation into a sound or an image. Okay. So what they are trying to do is they give an input, image or a sound, and then try to recreate that using a neural network. So at the output level, it's not the same thing as the input, but it is a kind of a representation reconstructed. Okay? So this is something you can see here. The brown ones are human inputs, and the blue ones are reconstructions. So this was trained. This was used on the cat model, which is trained with the cat drawings. And then when you give the human input, these reconstructions, if you see the ones at the to my left, that is to your right, a cat with maybe some 5, 6, maybe some different number of legs, and it has recreated something with 4 legs, because the data it was trained on, which are the cat drawings, doesn't have these kind of multiple number of legs. It just has 4 legs. So the representation that Z, if you remember that Z, has removed that number of legs and just reconstructed with 4 legs. And if you see the other one with three-eyed cat, so usually cats doesn't have third eye. I don't know if they have do some yoga or meditation, probably they can get that third eye. Unless the cat doesn't do that, it will simply have just two eyes. So our representation doesn't have that third eye. So it has removed it, and when it reconstructed, we simply get the two-eyed cat version. So the last one, a brush. Since it's a cat's, this model was trained on cat's images, brush is not something it has seen. So it gives something gibberish. So this one, I'm not going to explain this slide. I have seen similar things on Facebook, like if you are a genius, you can solve this. And if you, so this is something like that. Just give me a clap when you solve this. Until you give a clap, I don't do anything. Wonderful. So everybody a genius. We have a lot of genius here. Wonderful to see that. So this is what I was telling. So this, you can see when you draw a cat, the neural network will generate some random number of, this is actually 9 images of the cat. Same image, but it will reconstruct differently with the representation it has. And if you see that mosquito thing, it was trained on the mosquito image. And when you just simply draw a circle, here it was for the yoga. And when you simply draw one part of it, the neural network understand, okay, this is how it should be. If you want to draw a mosquito with a circle, how it should be, like what are the next steps that we need to follow. So you can get different kind of drawings like this with a particular input. Before that, I would like to show you a demo on that image drawing that I just showed you. So until we get it loaded, I would like to see some people ask. නිදාගන්නයි පොඩ්ඩ අතුස්සන්නකෝ. නිදාගන්නයි අතුස්සන්න. නැද්ද කවුරුවත් නිදි නැද්ද? ටැග් එකක් තියෙනවා දෙන්න ඒකයි. මට පේන්නේ නැහැ කවුරුත්. ඒ කියන්නේ නිදි නැහැ නියමයි. නිදි මතද? උත්තරයක් දෙන්න. මට ඇහෙන අඩුයි ටික. හා? ටැග් එකක් ඕන නම් කියන්න නිදි මත නැද්ද කියලා. හා? ශාස්ත්‍රාස් නිදි මතයිලු නේ. අවුල් ටී-ෂර්ට් එකක් දෙන්න. Never mind. So, right, we can show the other one probably. The drawings. Okay. Okay, this one. So you can see the rain model has been loaded. And when you simply draw a line, it will follow your patterns and it will simply draw a rain, right? If you draw a raindrop, you can see a lot of drops. So let's see what happens if we draw a cloud. It's related to rain. Let's draw a cloud. Can you see that? Isn't it cool? We just draw a cloud, and the neural network has simply draw some rain from that cloud. So it understands what we are trying to do. It's not programmed. I mean, it's not something programmed. It's not a video that animation that I created. So that guy is doing that demo right from there. So it's not an animation that I'm running. Okay. So you can see it by yourself if you go to Sketch RNN, if you search for Sketch RNN Magenta, and you can play around with this demo, right? So we can move to, maybe we can try with another model. Let's go to another model. Anything you like. Just pick something you like. Okay, it's a lighthouse. So let's see what happens if we simply draw a circle. Let's wait for it to load the model. So these models means it's kind of a, let's say, if you, a neural network, which is kind of a, just think it as a computer algorithm, okay? Just think like that. It's a neural network which is trained with data. So you have shown it some data, a lot of data, and it will understand. It will get an idea of what is the underlying patterns of that particular images. So that is something you call as a model. So if you draw a different shapes, it will try to reconstruct or draw a lighthouse out of that thing. Okay, so I think that's enough. They can try when they go home. So it's a homework for you. You can go home today, not today maybe, yeah. Today you are sleepy, so you can't just do this after going home. But anyway, when you feel free, you can go to Magenta Sketch RNN and try out these demos. Okay, so shall we move to our presentation? So I will talk about something called NSynth, which has the same kind of methodology that we were taught. Like we have a neural network, an encoder and a decoder, and this Z representation. Instead of image, here what we're going to do is we simply use an audio. So NSynth, first of all, I should tell you what NSynth is. NSynth is you mix two sounds and create new tones, new sounds. It's not just mixing those two sounds and come up with an average sound. It's like for example, if we try with violin and duck, how the let's come up with the name wild duck or something. So what is this new wild duck instrument sounds like? Okay, you will understand when we do a demo later on. So before that, I need to tell you something about this WaveNet. If you remember, during the keynote, Sundar mentioned something called WaveNet. It is used in text-to-speech systems, and if you see it like the understanding it gets not just from the present data, but it goes beyond. Like you have the coherence with the data when you use this kind of architecture or this kind of a new method. And you can, if you are too techy, you can read the paper which is published, which was published I think a few years back now by the DeepMind. So what we do here is, instead of just outputting the audio, we simply use that WaveNet vocoder. So in WaveNet, what it does is, given an audio, it will try to come up with an audio. Okay? So you train with bunch of audios, and you can create a text-to-speech voice. So here, in this NSynth, what they do is just use that WaveNet vocoder, which simply generate that voice part after the decoder here. Okay? So it's funny. Okay, this is the Z. If you remember that Z, the representation, this is how it looks like. The embeddings are here. So that is the original sound, and this is the embeddings. If you just visualize it, and this could be the output. So it will try to come up with this low dimensional, the dimensional reduction embeddings. When you are in that embedding space, you can manipulate these things and come up with new tones, right? So that is how it was reconstructed. You can get a good idea. Can we do the demo on the NSynth before playing the video? Yeah. So how many of you enjoyed the event today? raise your hands. කම්මැලිද event එක? හොඳයිනේ? නියමයිනේ? මාරු. So if you see it now, you can listen to that dog sound. Can we play the dog? It's dog. Is it dog? Let's come up. Okay, harp. I don't know what that is. Anyway, so that is harp. What is it? Okay, so those are the original sounds of those two, one instrument and the dog. Those are the original sounds. So if, okay, the sitar, let's say. So this is a sitar sound, and you know what dog sound is. So let's see if we combine those two things and come up with a new instrument. Maybe let's call it dog guitar or whatever, something. That's it, how it sounds like. It's not a mix, it's not just a blend. Do you get it? If you have a good auditory system, I think you can get it. Not just a mixing these two languages, it's just on the embedding state. It's just a combination of these two, manipulation of these two embeddings of these two audios. You can change the scale and see, like, make it more sitarist. I don't know whether that word correct. And you can make it more dogish. Right? Okay, let's play the video. So there's a video I need to show you which explain the synth much better than me.
I'm fascinated with this idea. Every time we see a new technology come along, artists take interesting bits of that technology and turn it into new ways of making music. From ancient instruments through to the 808 drum machine, transforming the technology into something of artistic merit. My name's Doug. I'm a research scientist on the Google Brain team, and I run a project called Magenta. We're a research group dedicated to understanding how to use machine learning in the space of the arts. We're not trying to make music making easier. We're trying to build some sort of machine learning tool that gives musicians new ways to express themselves. We're using neural networks in a novel sort of way. We're using neural networks to generate sound. Not the actual note that's playing, but the sound of the instrument.
And one of the first projects we worked on was NSynth, which stands for Neural Synthesizer. The NSynth algorithm learns the core aspects of what makes each sound like it does, and then combine those characteristics, drawing a new sound that's not just a blending of the two original sounds.
Okay, so the first surprise for me is that NSynth works at all, because it's technically a very complicated algorithm and one that was hard to train. And so we've needed to go from heavy math and big computers and lots of code to something that musicians could play. And so another group at Google, called Creative Lab, took the sounds from NSynth and created a musical instrument. We call it NSynth Super.
That's like wild to me. Here's a flute. Here's a snare. Guess in the middle, this is what it sounds like.
Now it does feel like we're turning a corner of what could be new possibilities. It could generate a sound that might inspire us.
The fun part is, like, even though you think you know what you're doing, there's some weird interaction happening that can give you something totally unexpected.
Wait, why did that happen that way?
This is our first foray into actually building tools for musical creativity. I would love to see people using NSynth Super in ways that surprise us all and gives us some new bit of musical joy in the world.
All right. So now you have a better idea about NSynth. So I think that's all from me. You can check out this project. Go to g.co/magenta, and you can get more information about Project Magenta. And thank you very much, and have fun. See you.